different graphs and their domain and range. So, as review, domain is what? The x values. Also known as the input, the independent variable. Excuse me. I'm losing it. And then the range. Or the output dependent variables. Forgetting. When we talk about domain and range here, there'll be two different types of graphs. One will be discrete, and those will be just random points on a graph. So they're not connected, they're just random ordered pair points. Or it can be continuous. So when we were finding the domain and range of the quadratic and the exponential, those were continuous functions that started at one place and it kept going. So those usually have a line or a curve. All of your linear functions are continuous. Now this part is really review. It's just adding in your x and y intercepts. I think you guys have more on this than I do. But I'll go back. So a continuous function has a y-intercept or x-intercept. And then you guys, my voice is cracking, have this part, which is review. So x-intercept, also known as a solution, as a zero. This one is zero. Because it would make the function zero. This is also a solution or a root. Just to remind us what our x-intercept is called when you see it in different formats. So the first couple examples will just be domain and range. Is this a function tying into the relations and functions? And then the ones after that will also ask about x and y intercepts. So because we first have to decide, is this discrete or is this continuous? Based on this. Is it a graph that consists of random points that aren't connected, or is it a continuous graph? It's discrete. Right. So because it's a discrete function, we're going to list out our domain and range in a set. So using curly brackets, least to greatest. So for our domain, what would our furthest point to the left, what would that be? -4, keep going. What's the next point? -2, keep going. -1. 1. 2, 3. If you had any on the same x value, you would only put that once. And then range, we're going to do the same thing, but lowest to highest. What's the lowest y value? Keep going. So then that would be our domain and that would be our range. Is this a function? Does it pass a vertical line test? / does it have any repeating x's? Yes. It passes the vertical line test. It doesn't have any repeating x's. Questions on that? Go on to the next one. So then for this example, what would that come first? Is this discrete or continuous? Discrete. There are a bunch of random points all over the place. So again, this is going to be a set of numbers. So where does that start? Okay, and then keep going. Where else?
2.
I think this was actually at -3. And then 2, and then 4. Okay, and then range, lowest to highest. -8. -8, -4, -3. Is this a function? No, why not? No, we not pass the vertical line test. It has 2 repeating x's going to 2 different y values. Any of those. Questions there? Now, on example 2, what type of graph is that? Continuous. So if you see lines, that's going to be continuous plus. So we're going to do that domain and range a little differently. Just like with our quadratic and exponential, we want to look from start to finish. We don't want all the numbers in between. I'm going to write this in both ways, set builder and interval notation, because we're used to interval notation, but not used to set builder, and we've got to get used to set builder. Okay, so for our domain, if it helps, because we have endpoints, you could draw in where your endpoints are. And we'll start with this domain. And those endpoints are going to be your start and your end. Those are going to be the only 2 numbers you write. So this, I'll start in set builder notation. All set builder notation starts with curly brackets, sorry. Whatever you're looking for, so domain is x, and then you're just going to draw a straight vertical line. It always starts that way. Then, this starts where? -5. You're going to go ahead and put -5. When it's in between 2 numbers, you're going to put the number, and then because these are closed points, less than or equal to, you're going to put x in the middle, and then where does this stop? Where does it end? 6. Oops, I missed a step. Less than or equal to again, and then 6. And then curly brackets. So kind of like when we were writing our compound inequalities or absolute value inequalities, we wrote it like this. Same thing. You're about to ask something. All of these are x values. We're just looking for where does it start, where does it end. We wouldn't write all the things in this. Because this is saying starts at -6, -5, and ends at 6 in everything. Other questions on that? Now, in interval notation, because these are both closed points, these would both be square brackets. And you would just write in square brackets -5 to 6. Both of these mean the same thing, but on the SOL you may see the set builder more than the interval notation. And you have to know that they mean the same thing. Questions? Range, we're going to do the same thing. If it helps you, again, put a line at where your lowest point is and where your highest point is. Be careful, look for the highest, not just wherever's in between.
Where are the 2 points from?
So, like this.
Yeah, like if you build 2 points, like if you draw a line, 2 plus 2 points.
Like if this went up here, that would be fine. You're looking for highest and lowest. That doesn't matter.
Okay, which would be the one?
The highest. Or the lowest, whichever it is. So then, just like this, it's going to start out the same way, curly brackets, but now it's range, so y. And then the vertical line. What is our lowest point? -3. These are again closed, so less than or equal to. And then y instead of x, less than or equal to, what's the highest point? 4. Curly brackets. Or in interval notation, square brackets, -3 to 4. Because we've already done x-intercepts and y-intercepts, find those. What are the x-intercepts of this?
Oh,
The x-intercepts. 2 and -4. It's a little off, but let's assume it's there. So we'll just write those as ordered pairs. And then the y-intercept? -1. Mine's a little off. If yours is at -1 for that, I'm going to put mine at somewhere in between there. If yours is exactly at 1 or -1 or -2, you can put that. Mine is just not. Is this a function? Yes. It passes the vertical line test. You have any questions so far about domain and range? We'll do another one together and then I'll have you try one. So again, if you want to put in the lines, you can do that. For the domain, where does this start? -4. And I would start that curly bracket, x, the line, -4 is less than or equal to x, which is less than or equal to 5. Curly brackets. Or -4 to 5 in square brackets. For the range, lowest to highest. So curly brackets, y, the line, -6 is less than or equal to y, which is less than or equal to 6. Curly brackets, or square brackets, -6 to 6. What are the x-intercepts? If yours goes through 0, 0, put that. Mine does not. Mine is like in between. Y-intercept. So if yours goes through 0, 0, yes. Mine does not. Is this a function? Yes. Most linear functions are, unless it's a vertical line, then it's not. Do you have any questions on that one? I want you to try the square rectangle on the next page. I'll give you a couple minutes to do that, and then we'll come back and talk about it. What was the domain for this? So start it from the beginning. And then if we were writing that in interval notation, negative 5, 3, 4, that should be 4. Okay, and the range? And then interval notation, negative 5. The x-intercepts for this are what?
Negative 5, 0, and 4, 0.
Negative 5, 0, and 4, 0. And the y-intercepts?
0, 6, and 0, negative
0, 6, and 0, negative 5. Is this a function? Do we have any questions? So we did some discrete ones. We did some continuous ones where they had endpoints. Now we're going to talk about some graphs that don't have endpoints. If it has arrows instead, what happens then? Now we did quadratics, and this is that. So we should know the domain image of this, but we'll still try this one. So you can still draw in your lines if you want. Domain, you're still looking left to right. But if it has arrows, the arrows, you have to imagine it going off the graph forever and ever in that direction. So where will that start? Negative infinity.
Negative.
And then where would it end? And if it goes in both directions, negative and positive, in set delta notation, starts off the same way, but that's where the fancy X, this weird E, like a backwards 3, and then this double R. It doesn't have to be perfect, but just make it look like that to the best of your ability. In interval notation, we know it would be negative infinity to infinity. But we would say that's all real numbers. Range, we're looking lowest to highest. What's the lowest value? Negative infinity. I'm going to do the interval notation first. And then what's the highest value? Not infinity. It has a stopping point. It is 3. So in this, it's not going to be the same. Sometimes they are different. It's going to be everything below 3. So it starts off the same way, but it's going to be y is less than or equal to 3. So anytime infinity or negative infinity would be in the answer, you're either going to have all real numbers or a less than, just one, less than, or greater than, depending on the way it's, the direction of it. What are the x-intercepts here? Yours may go through that, mine don't, but you can write that. Mine are a little off. And then the y-intercept? 0, 3. Is this one a function? Yes. All quadratics are functions, yes. Now, if you see a sideways quadratic, 1 that's not a quadratic, and 2 is not a function. Do we have any questions with that? So it literally reads x such that x is an element of all real numbers. But in summarization, it means all real numbers. It means the same thing. Okay. And example 4, what would that domain be? Two. And what would that be in set builder notation?
Just add one backwards.
You just call it E. It's all real numbers. What about the range? Does it stop at 2?
Yeah.
It goes to infinity also. So then how would we write this? So all of your lines have domain and range of all real numbers. They go on and on for every number in both directions. X-intercepts there? Sure. And y-intercept? 0, 2. Is this a function? Yes. Do you have any questions on our notation or anything so far? I want you guys to try the next one. Anyone think they know the domain of this one? Not less than. It's going to be greater than or equal to 0 because it's everything to the right of 0. Or in interval notation, that would be start at 0 and go to infinity. What about the range? It is E1. Because this keeps going down and up, so it goes to negative infinity and positive infinity. X-intercepts? Y-intercept? Is this a function? No. Do we have any questions on this?
How do you have an interpretation of the
Look at the practice problems on the next couple of pages. Are there any of those we want to see you go over and have questions about? Or the one with like the S in the middle?
Yeah.
This one. Any others? Or do you want to write, we'll do this one too, and then that'll probably be a good sum. Yeah. So domain, look at the furthest points. Where does that start? Where does that end? The positive infinity. So that would be what?
35.
So in, yes, curly brackets.
X, Y, X, E,
All real numbers. And then what about our range? And say what you're thinking is not.
There's like negative 6 is less than equal to.
So this one has lowest and highest points. It doesn't keep going forever and ever. So negative 6 is less than or equal to y, which is less than or equal to. They can be different, it just depends on the function. X-intercepts, does it have any?
No.
No, so we can put NA. Y-intercepts, it has 3 different ones.
0, 2, 2, -4, -6.
Is this a function? It does not pass the vertical line that's in there. What would the domain of this next one be? Okay, so you're all real numbers. What about your range? Something about 4, yes. Does y ever move from 4? No, so it's just going to be y equals 4. If you get something that's just a straight line, it'll be something equals, depending on what that line is. Do you have any x-intercepts? No. And y-intercepts? 0, 4. Is this a function? Yes. Horizontal lines can be functions. Vertical lines cannot be. This is a vertical line, it therefore doesn't pass the vertical line. Okay. We're going to stop there. Tomorrow, if we have any other questions we want to see you go over, we'll do that, and then you'll have more time to practice. So if you want to practice some more for the next 5 or so minutes, you can. If not, you can get your calculators up.